Welcome back everyone to a session on Big Data Analytics. We have already completed 2 chapters of Module 3, that is Business Intelligence and Data Warehousing. In today's session, we will look into a new chapter where we will be learning the concept of data mining. First, let us see the definition of the data mining. Data mining, as per the definition of the prescribed textbook, is an art and a science of discovering knowledge, insights and patterns in the data. You can find various other definitions. For example, in some other textbook you can find it as a data mining is a process of extracting useful information from a large data repository. Okay. See, normally the flow of data, the data will be normally stored in a database management systems, right? And from here it will go to data warehouse, and this will be fed to the various data mining tools or algorithms. So the data, usually for the data mining algorithm, will come from data warehouses, and the output of which will be given to the various data visualization tool. Okay, but this need not be the only source of data for data mining algorithm or tool. Okay, it can come from other sources also, but this is the normal scenario where the data, the flow of data happens. Okay, data will be generated from various sources which will be normally stored in database management system, which goes to the data warehouses through which data analysis and the data will be summarized. The subject oriented data will be kept for decision making, right, for the generating of report and also to perform data analysis, and this will be normally fed to the various data mining tools or algorithms which performs various operations in finding a useful patterns in the data. Okay, and this goes to, and the result of which will normally go to data visualization. So this is the flow of data. Okay, and it is not necessary that the output of data mining should go to a data visualization part. Okay, yeah, having said this, this is the flow of data, and this need not be the only flow of data to the data mining tool. Okay, but this is the a normal scenario in a enterprise. Okay, let us come back to the definition. So it's an art and science of discovering knowledge, insights and patterns in the data. Main thing is patterns. So what kind of pattern? So for example, a customer who buy cheese and milk also buy bread 90% of the time. So this is a useful pattern in the data, right? In the transaction of a customer in any shopping grocery store, and this would be a useful pattern for any grocery store through which they can stock the products appropriately. And similarly, another example would be like people with the blood pressure greater than 160 and age greater than 65 were at a high risk of dying from heart attack. So this is again um, a pattern in the data, which is very helpful in assessing a medical condition of a person, and this can be a great this can provide a great diagnostic value for the doctors. So these are the patterns what I am talking about, and the field of data mining is actually emerged in the context of pattern recognition in defense, such as identifying a friend or a foe in a battlefield. Okay, so now let me explain this overall concept of data mining in a pictorial manner. Okay, so what we can see here, this is a picture of a gold mining, a picture of a gold miner mining for a gold, right? So let us do some comparison or analogy. Okay, so what we have here is a person, right? So I can compare this as a miner. He is the data miner. Okay, and here we have the large chunk of data. This entire black mountain or a dark colored mountain is a data, and in this huge data we have some useful patterns, so which is the useful information, right, which is necessary for decision making, and also uh, which helps a lot for an organization, or depending on the problem statement, to extract some the insights into the data, right. And it is the job of the data miner to extract this pattern from this huge repository of data. Okay, but unfortunately he can't do it alone, right. So what he requires a data mining tool. Okay, so this is the data mining tool or a data mining algorithm. Okay, so using this data mining tool, data miner or end user should be able to extract these useful patterns or information from a large data repository, right. And after mining, what you can do, you can make use of this information. So this is already the pattern that is obtained from the data, and which can be given to the various output of data mining. I can say that this will be the output of the data mining operations. Okay, this can be used in data visualization, which in turn will help make a lot of useful decisions, and will be able to provide a lot of knowledge and insights into the problem statements, or into the uh, data repository what the company or an organization is having. Okay, so this is a simple but very useful analogy about the data mining. Okay, now let us go to the next slide. Now let us look into some of the aspects of data mining. So before going into the data mining algorithms, we need to collect and gather the data, right. So let us discuss about that. Before going into the various uh, points with respect to gathering and collecting data, let me put some interesting facts that will wow you regarding the amount of data that is currently being generated in the world. So if you see, for every 2 days we generate enough data, or as much as data that we had from the beginning of time till 2003. So this is being generated for every 2 days. Okay, and over 90% of the data currently present in the world is created in the last 2 years, and for every 18 months the amount of data what we have gets doubled. Okay, so this, just imagine the volume of data that is currently being generated. And one more interesting fact. See, if you burn all the data that is currently present with us onto a DVD, and if you stack this DVD on top of each other, then this would reach the moon. Okay, the stack of DVDs would reach the moon. So this is the amount of data what we have. And this is a new trend. The large amount of data is being generated in a large volume in the last last decade, and again this will continue in a very exponential manner. So gathering and collecting data is a it's a very it's not so not an easy task, right. Out of this volume of large data, we have to gather the data that will provide the insight into the needs of the business. Okay, let us see some of the points with respect to gathering and collecting data. First one is what and what not to. Okay, so this is about making a judicious decision about what to gather and what to ignore, and this should be based on the purpose of data mining exercises. So this is like deciding where to fish, as all the streams of data will not be equally rich in potential insights, right. So out of this large volume of data, we should decide what kind of data need to be uh, gathered, collected, and what to be ignored, and this is a very challenging task, as the volume of data being generated on a daily basis is very large. Okay, even for any small business or uh, any kind of organization. Second one is data to be effectively gathered, cleaned, and organized. So this is about to learn from the data. Quality data need to be effectively gathered, and it should be cleaned and organized. Then only we can perform some efficient data mining algorithm on it, right? So one requires the skill and technologies for consolidation and integration of data elements from multiple sources. And this most of the organization develop an EDM, that is enterprise data model, to organize their data. And now let us see what exactly this EDM is. Okay, so this stands for enterprise data model. So EDM is a unified high level model of all the data stored in an organization's database. And the EDM is usually inclusive of data generated from all the internal systems, and the EDM provides the basic menu of data to create a data warehouse for a particular decision making purpose. Okay, and further, the data warehouse will help organize all the data in an easy and usable manner so that it can be selected and deployed for the mining operation. Okay, so this is about EDM. So EDM is it is used by the organization mainly to data organize the data into a model, and normally that will be kept in a data warehouse from which the data mining tools can gather the data and perform operations. Okay, next point is gathering and curating data takes time and effort. Yes, so particularly this is when it is when the data is unstructured or semi-structured. So what do you mean by unstructured data? Unstructured data are images, text, videos, social media comments. So all these are unstructured data, and this unstructured data should be handled in a very right manner, right? It should be cleaned. Again, it should be ordered, organized, and it should be also decided whether to keep such unstructured and semi-structured data for data mining purpose or not. Okay, and yeah, there are streams of unstructured social media data from blogs, chats, and tweets, and there are streams of machine generated data which is also collected from various RFID tags and Internet of Things and so on. Okay, so this takes a lot of time and effort. Next point, the data gathered should be relevant and suit the problem being solved. Of course, the data collected should match up with the problem statement in hand, and then only it can be used, right? The data can be collected from data warehouses, as I explained. See, that normally the data to the data mining tool comes from the data warehouses. It is not necessary that it has to come from data warehouses, but normally it comes from the data warehouse because the data is already cleaned and organized, and it is stored in some desired schemas like star schema, right? So with which it is very easily the data can be collected, and it can be fed to the various data mining tools or algorithm. So this is about gathering and collecting data which is required for the data mining purpose. The next important aspect of data mining is data cleansing and preparation. So this is a very important pre-processing operation with respect to data mining. So one may say data mining, choosing the right data mining algorithm or applying the data mining algorithm is the important factor in a data mining project. Actually, Yes, we can agree, but it is not the most time consuming operation. The pre-processing operation of any data mining operation or data mining project is the most labor intensive and time consuming operation. uh, this cleaning of data and preparing it for the next stage, that is to the the cleaned data which will be given as an input to the data mining algorithm takes 60 to 80% uh, time of the entire data mining project, and this is something which is manually done, or it's a semi automated activity. Okay, and as said, it is a very highly time consuming operation, and uh, of course uh, so much of time is really required for cleaning the data, because we don't want to give the low quality data to the data mining algorithm. So if we give a low quality data, then it is like garbage in and garbage out. We are feeding the garbage into the data mining algorithms, and it will not provide us the right output or right insights into the a problem. It will not be a very effective output. So it is very necessary that we have to clean the data and make the data ready um, to the greatest extent possible. Okay, now let us see the various operations that need to be done in cleaning the data. The first one is duplicate data need to be removed. See, this is something what you might have done in your what you call machine learning mini projects, something like that, right? Before applying any machine learning algorithm, we will clean the data, or we will handle the duplicate data, and we will do a lot of pre-processing operations, and one of the pre-processing operation is about removing the duplicate data. So on why duplicate data comes into the why it is gathered. See, the same data may be received from multiple sources, and when merging the data sets, these data must be removed. Okay, so we don't want duplicate data to affect the output of our data mining projects, right? So the duplicate data need to be entirely removed from the data set that will be fed as an input to the data mining algorithm. Okay. Second one is missing values need to be filled. Of course, this is another important pre-processing operation. Missing values need to be filled in. So we have to handle the missing values in some right way. Okay. For example, we have a data to decide whether a patient is having a heart related disease or not, and it relies on multiple factors, right? Suppose in one row, or in one particular record, the patient's name is missing. So if the patient name is missing, what we can do is we can simply put some dummy name, because patient name does not impact in deciding whether he has a heart disease or not. It is just data to identify a patient, and it does not determine whether, or it does not play any role in deciding whether mm, a person is having a heart attack or will have a heart related disease or not, right? So in such case, what we can do, we can fill a dummy value. Okay, dummy value. What about if the patient is age is missing? Then if the patient's age is missing, then we cannot fill a dummy value, because patient's age plays a major factor in deciding whether a person will be having a heart related disease or not. In such kind of situations, we have to handle this data uh, in a very effective manner. One thing what we can do is we can totally ignore this data, or we can simply remove this row, as it may mislead in deciding the outcome of the data mining project, or we can we can put the average value of the age from rest of the records. Okay, so this is what we can do. So either we can make an average, or we can remove the record. So this missing data, missing values in the data need to be filled in, or it has to be on a right way. Right appropriate word is, it should be handled in a very right manner, such that it will not impact the outcome of the data mining task. Next one is, data value should be comparable. So data elements should be comparable. That is, the data elements may need to be transformed from one unit to another, and the data should be stored at the same granularity to ensure the comparability. For example, the sales data may be available daily, but the salesperson compensation data may only be available monthly. So to relate these variables, the data must be brought to the lowest common denominator, in this case, which is a monthly. Okay, and one more point with respect to comparability is, um, the, the data need to be adjusted to make them comparable over time. For example, the currency value need to be adjusted for inflation. So it requires to be converted to the same year of comparability. So these are the uh, factors what we have to perform. Okay, data value should be comparable. Next one is, continuous value need to be binned, of course. So sometimes we will be having a continuous value which is um, which need to be binned, in the sense it need to be converted into some categorical value. So why it need to be converted into categorical value? Because the continuous value will add on a lot of weight into the processing operation. So once um, once you add this data to the data mining task, the continuous value will make the data mining algorithm um, take more time to come to a conclusion. And also, for the sake of simplification, we may require to lower this or convert this continuous value into some categorical value. Okay, for example, um, bin it in the sense, to a few buckets. We can bucket some continuous value into few buckets. For example, work experience can be bucketed into low, medium, and high, right? So this experience is normally a continuous value in terms of years, right? One may have 0 year of experience, or one may have up to 40 to 50 years of experience. uh, so the number 40 to 50 is an experience, is 40 and 50 years is not normally. Yeah, let me reduce it to 30 to 40, 30 to 30 years of experience in any field, right? So having 30 years of experience and 35 years of experience doesn't make a lot of difference with respect to his expertise, right? So what we can do is, anything above 25 may be converted or may be treated as a high level of experience, and anything below 25 to 15, or 10 to 20, or 10 to 25 rather, can be treated as a medium level experience, and anything between 0 to 10 can be treated as a low level of experience. Because see, the experience between 7 and 7 6 and 7 will not make a huge difference, right? But the number 6 and 7 are two different numbers if it is fed to the data mining algorithm. So what we can do is, we can simplify the task by having some category. Okay, so this is something what we can do. Continuous value may need to be a bit. Next one is, outlier data need to be removed. So what do you mean by an outlier data? The data that is abnormal with respect to the rest of the large set of data. Okay, the data which is hugely outside the uh, outside the realm of the usual data, right? So what we can do? So this has to be carefully reviewed. See, I cannot directly say that it need to be removed. It depends again on the task at hand. Okay, normally the outlier data is removed when it comes to classification, and when it comes to regression, such kind of task. But um, in uh, in some of the operations like anomaly detection or fraud detection in a transaction, outliers itself is something what we are looking for, isn't it? Outlier, because anomaly detection is an abnormal behavior in the data, and these abnormal behaviors are actually the outliers, so we cannot completely ignore the outliers. So these outliers has to be carefully handled depending on the data mining task we have. So if it is a classification, if it is a regression, or if it is a clustering kind of operation, then we can ignore the outlier. But if the data mining task on hand, if it is a fraud detection or any sort of anomaly detection, then the outlier cannot be or shouldn't be directly removed from the data set, because the one what we are looking for itself might be the outlier, right? So this has to be handled in a appropriate manner. Next point is ensure that the data is the representative of the phenomena. So here uh, what we do, what we highlight is the data under analysis should not be biased. Okay, so under analysis, by correcting the for any biases in the selection of data. So while selecting the data for either training or testing purpose, we should not perform bias. For example, if the data includes more members of gender, then um, it is a typical population of interest, then adjustment need to be applied to the data. So if the data is having only a certain gender, then the data become imbalanced, right? So the data is rather unbalanced. The data is unbalanced. So such kind of unbalanced data need to be sorted out. Okay, so you have to make sure that the data is balanced, and the data may need to be selected to increase the information density. So some data may not show much variability because it was not properly recorded or for some other reason, and this data may dull the effects of other differences in the data and should be removed to improve the information density of the data. Okay, so we have to identify such records in the data that may have some that may not show a lot of variability. Okay, so such kind of data need to be dealt in a right manner. So this is about the pre-processing operation of data cleansing and preparation. Now let us see the next one. The next topic is about the output of data mining. The data mining techniques can serve different types of objectives, and the outputs of this data mining will reflect the objective being served, and there are various ways of representing the output of a data mining task. And one of the most popular way of representing the output is in the form of a decision tree. Yes, it is the same decision tree what we have already learned in our previous semester, machine learning, right? And this is something not new to us. But again, let us, anyways, we will be learning about this decision tree in detail in the upcoming module. There is a dedicated chapter for decision tree in module 4, and little bit of again explanation of decision tree in this chapter itself. Okay, we'll be looking at in detail anyways, but before that, let us recall what exactly a decision tree is. Decision tree is a hierarchical structured tree or a branched structure that helps visually follow steps to make a model based decision. So an example of a tree would look something like this, right? So it's a tree which is having nodes and branches, and based on certain criteria, it will perform some branching, right? Or it will make some it will help us to make some decision. Okay, so for example, I have a tree here written on the right part of the screen. Assume that I have a tree to decide whether or to predict whether it will rain tomorrow or not. So the prediction of whether it will rain or not will be based on multiple factors. So we will at each node, we'll start from this root node, we will check for certain condition, and if it is true, I will branch to, if this condition, let us not bother about what exactly the various conditions to determine whether it will rain or not, because anyways we will be learning in detail about how the decision tree works with an appropriate example in the upcoming module. Okay, so this is just a representation of a tree. Okay, so here I will check for certain condition, and if the condition happens to be true, I will branch towards the left part. Okay, and here also I'll check for certain condition, and if the condition happens to be true, then I can predict that it is going to rain, and if this condition is false, then I can predict, or I can classify that it's not gonna rain based on the current data what I have. Okay, so this is false. And if the original condition was false, then I will check another I'll go to the right and check for certain condition here, and if the condition happens to be true, then I can pretty much say, or I can decide that it's gonna rain tomorrow. And if it is false, then I will check for another condition coming towards the right, and based on the outcome of this conditions, based on the data what I have, if the data happens to be true, then it's gonna rain, and if it is false, then it's not gonna rain. Okay, so this is the prediction what I do by making use of decision tree, where the decision flows visually, right, from the root node towards the leaf nodes, and the leaf nodes will answer, or the leaves will answer whether it will rain or not. So that is the output of this particular data mining task. And so this is one of the classic example of the output of a data mining task in the form of a decision tree. So this decision tree can be mapped to various business rules, and if the objective function is prediction, then a decision tree or a business rules are the most appropriate mode of representing the output. Okay, so this is one thing. And the other way is regression equation or a mathematical function. Again, so this again depends on the problem statement what I have. We all know what exactly regression equation is and why it is required. So regression equation is also machine learning. It comes from artificial intelligence domain, and which is used to predict a continuous value, right? The output can be in the form of a regress equation that represents the best fitting curve to represent the data, and this equation may include linear and non-linear terms. And the regression equations are a good way of representing the output of classification exercises, and there are also a good representation of forecasting formula. Okay, so what example we can take? For example, regression, we can make use of regression to predict the price of the land, or the price of the home or a house in a particular area, right? So where we have a continuous value rather than a classification labels, right? So in the previous one was about labeling. By using decision tree, we have labeled whether it's gonna rain or not. So there are two possible values, yes or no. When it comes to predicting the stock prices, or especially with respect to finances, we have a continuous value. So here we have to make use of regression equation to predict the most appropriate value for the given data what we have. Okay, the classic example would be predicting the stock prices, or predicting the land price or house price given the various data. It may depend on various factors such as the location of the house, the number of bedrooms, the size of the hall, and the age of the house. So all these things matter in deciding the price of the house, right? So this is about This is another way of representing the output of a data mining. All depends on the objectives that is served by the data mining task. Okay, and these are the two popular outputs, and these are not only, these are not the only output or possible way of representing the output. Again, this depends on the task what we have. For example, um, if the task is with respect to association analysis, then the output might be represented in a different way. For example, business rules are appropriate representation of the output of a market basket analysis exercise. So these are the rules where we have if-then statements with some probability parameters associated with each rule. For example, those who buy milk and bread will also buy butter 80% of the time. So this is another task. We call this as association analysis. Okay. So these are how the output of a data mining tasks are normally represented. Okay.
So the next task after obtaining the output, we have to evaluate the result of data mining task. We have seen how exactly the output of a data mining task is represented, either in the form of a decision tree or a regression equation, or in the form of a cluster, or in the form of a business rule, that is association analysis, or a basket data. But again, that depends on the data mining task on hand. That depends on the objective what we had. After obtaining the output, it is very necessary that we have to evaluate the output or evaluate the data mining results. Broadly, see, this data mining task can be broadly classified into two types: supervised learning and unsupervised learning, something what we have already learned in machine learning, right? And first, let us see the supervised learning. It is a machine learning approach that's defined by its use of labeled datasets, and these datasets are designed to train or supervise the algorithm into classifying the data or predicting outcomes accurately. And a decision tree is one of the classical example, or the most used example of classification, and a very good example for a supervised learning, right? And using the labeled inputs and outputs, the model can measure its accuracy, and it can learn over time. So this is how we normally evaluate the result of a data mining task, by using the accuracy, predictive accuracy. But this is not the only way of representing the output. There are various other ways of evaluation. For example, by making use of the confusion matrix, I can evaluate in other way also, like I can make use of precision, I can make use of recall or F1 score. But predictive accuracy is the most used and most accepted evaluation technique. Okay, but if the data on the hand, if it is highly not imbalanced, if it is not balanced properly, that is, if I the predictive classes are not balanced with respect to the numbers, then I have to go with some other technique. But this is the usual or this is the most followed evaluation technique, that is accuracy. And how to what is the formula for predictive accuracy? It is the total number of correct predictions divided by the total predictions. Okay, so this is the formula. So if there are total 100 data sets to be trained, out of which if the machine has given me 88 correct predictions, then my predictive accuracy will be 88%. That is 88 divided by 100, which is 88%. Right, 88%. Of course, it will this will give me 8.8, but when it comes to representing in percentage, I have to multiply this again with 100, which will give me 88%, right? So this is the normal flow of approaches in evaluating the data mining task, supervised learning. So what I have is a training data, and I pass it this to the learning algorithms, based on which I'll be able to design a model, and this model will continuously learn by itself. And then what I do is I will pass the test data onto this model, and it will predict whether or it will be able to perform the data mining task. Okay, and the predictive accuracy is obtained, or this is evaluated, the working or the model is evaluated by using this formula, predictive accuracy, which is the total uh, prediction divided by the correct prediction divided by the total predictions. Okay. Okay, yeah, as said, we have a confusion matrix to represent the predictions. So what we have is a matrix, and these are the four values which I have to look into to clearly understand what's going on. Okay, so on the column I have the true class. So this is the real class value. Okay, real class value of the data. So I am here talking about some binary classification. Okay, and this is, so in a binary classification I have two possible values: yes, no, true, false, 0, 1, isn't it? So positive and negative. Okay, so this column represents the positive value, maybe yes, or this may be representing a negative value, which is no. Okay, so this is the true class. Okay, which is represented in column, and on the row I have the predicted class. This is what is predicted by the model what we have designed. Okay, and this is predictive class, which is true. Let me name it as yes, and this is the predicted negative class, and we have four possible prediction: true positive, false negative, and true negative. So let us see what exactly these values are. See, so the true class here is positive, and it is also predicted to be positive, right? So the actual value of this class is yes, and it is also predicted to be true, that is yes. Okay, so yes is the one of the label. Let us assume that it is one of the label. So it is actually positive, actually it is yes, and it is also predicted to be yes. So we have it as a true positive because it is correctly um, predicted, right? Correctly predicted. And here, let us come to this one. It is actually no. The value is actually no in reality, but the model has predicted it as yes. Okay, so we can say this as false positive because this is actually wrong, but my model has evaluated it to be true. That is, it has evaluated it to be yes, which in fact, as a matter of fact, it is actually false, which is actually the value of this data is no, right? So we represent this as false positive because it is falsely predicted to be positive by our model. Okay, so this is about true positive and false positive. Let us come to the next one. Yeah, so this, see here, the column is positive, and here the row value is negative. So actual value of this data is actually, it is a positive, but our machine has unfortunately said that it is a negative value. So we classify this, or we label this as false negative, because in reality it is positive. The actual value of this particular data set is supposed to be yes, but our machine has predicted it as no. So it is false negative. And the last one is on the column I have negative, and here on the row also I have negative. So what does that mean? The actual label of this data is no, and my machine is also saying that it is no. Okay, so it has predicted very properly, very proper, or it has predicted mm, with a proper label, right? Okay, now uh, students, think about this, which to have a high accuracy, which of these four values should be high, or which value should be greater in number? It should be true positive and true negative, because that is the uh, correct prediction done by our model. So if this value is high and this value is high, my overall prediction accuracy will also be very high, right? Okay, so how we can change this, or how we can represent this formula with respect to confusion matrix? So this total prediction or correct prediction is nothing but true positive and true negative, isn't it? And what is the total prediction? Total prediction is nothing but all these four values: true prediction, true positive, false positive, plus false negative, and true negative. So this will be the formula to represent the predictive accuracy, where the data is represented in the form of a confusion matrix. Okay. Okay, now let us assume that my confusion matrix is having value something like this: 20, 80, 10, and 0. So this means there are 20 true positive, 0 0 false negative, and 10 false positive, and 80 true negative, right? So how what will be the predictive accuracy? Predictive accuracy will be 20 plus 80. Okay, so this is about true positive and true negative, divided by all the value, that is 20 plus 80 plus 0 plus 10. Okay, so this is basically 100 divided by 110. So what will be the value? It is around, so let us let us calculate. It is 100 divided by 110, so that I will get around 90% accuracy, roughly. Okay, appropriately, my model is 90%, has 90% accuracy. So what does this mean? This means if I pass any test record to my model, and if it gives me the answer as yes, okay, or if it performs some classification as yes, then this that record can be labeled as yes with the 90% accuracy. Okay, so there is a 90% chance that my model has correctly predicted the label of a given record. Okay, so this is the meaning of predictive accuracy. And in any for any data mining task, if the predictive accuracy is more than 75 percentage, then it is accepted. Okay, it is accepted. But if you get as a predictive accuracy as equal to 100%, then that is the best possible model we have, right? But when if you design any machine learning tool which gives me 100% accuracy, then definitely there is some problem with the design. You normally we will not get 100% accuracy. If and all, if we get 100% accuracy, then there is some problem with the data set. Definitely with using the maybe the test data, the training data what we have chosen might be very small, or We did not consider the balance between the various labels in testing the data. So there will be, so it is highly suspicious if we get 100%. But um, roughly anything above 75% is accepted. Okay, so this is about evaluation of a data mining results, especially for supervised learning, which is normally represented in the form of a decision tree or a regression equation. Now let us see the how the it is measured with respect to unsupervised learning. So unsupervised learning, we have clustering and association learning, association analysis. So here we don't have labels, isn't it? And uh, there is no good objective measures for evaluating clustering and also association mining, and there is no single right answer for the result of these techniques. So it is not possible to have a great evaluation on the output of unsupervised learning techniques. So what is unsupervised learning? In an unsupervised learning, we don't have the labeled data set. So for example, clustering. In clustering, we don't have labels, right? We simply group a bunch of data that are very similar to each other, and we form a cluster. So there is no proper uh, way or no appropriate way of evaluating the clustering output. That depends on the performance of a cluster. Again, depends on various factors, the number of clusters what we choose and the algorithm what we choose. So we can say that the evaluation on of data mining results for unsupervised learning is not very clear, as we cannot measure the evaluation, and there is no single right answer for the result of these techniques. So this is about evaluation of a data mining result. Now let us have some insights into the various data mining techniques. As previously said, the data mining techniques are broadly classified into two types, that is supervised learning and unsupervised learning. And we have just seen how to evaluate a supervised learning technique, and also how it is not possible to correctly evaluate an unsupervised learning techniques. Because a supervised learning in a machine learning it is a machine learning approach that is defined by its use of labeled data set. So here the data sets are designed to train or supervise the algorithm into classifying the data or predicting outcomes accurately. And here the data is having labeled such as input and output. So where we have a dependent data and independent data. Using the independent data, we should be able to predict the dependent value of the outcome. So this is about supervised learning, and the classification, which is a machine learning technique, comes under supervised learning, where we are supposed to classify the label of a, where we are supposed to predict the class label of the given record based on the model what we have designed. And here we can make use of models such as decision trees, artificial neural networks. Then we have support vector and naive Bayes methods, which is a very efficient techniques in performing classification. And on the other hand, I have classification with respect to statistics, where where we can make use of the domain area of the statistics in order to classify the value. So this is with respect to continuous value, where we can make use of regression equation. We here for example, suppose we have to make the prediction about the future stock price or a land price, so which is a continuous value rather than some categorical value. So here we require the use of statistics. uh, from the field of statistics, we make use of this regression equations to predict the value. So this is about supervised learning. And unsupervised learning is more of an exploratory analysis to discover useful pattern in the data. Okay. So why it is named as unsupervised? Because here the machine here it makes use of the machine learning algorithm to analyze and cluster unlabeled data sets, and these algorithms discover hidden patterns in the data without the need of human intervention. So hence they are called as unsupervised. So it does not require human intervention because there is no label with respect to data. So this is not about classification. Here it's all about analysis or discovering the patterns in the data, okay, mainly to form a cluster. So it is useful in cluster analysis and association analysis rules. So what is a cluster analysis? So clustering is a data mining technique for grouping unlabeled data based on their similarities or differences. And as mentioned, k-means is one of the most famous clustering algorithm, which assigns a similar data points into groups where the k value represents the size of the grouping, and it also represents the size of granularity. Okay, and this technique is helpful for market segmenting, image compression also. Then we have association rules, so where we can make use of algorithms such as a priori to um, to perform analysis on market basket data. And what is association rules? Association is another type of unsupervised learning that uses different rules to find relationship between variables in a given data set. And these methods are frequently used for market basket analysis and also for recommendation engines, where say you might have seen something in recommendations in YouTube, right? Where automatically you will be recommended with various videos. That is again dependent on the various variables such as your past views and also the likes what you have um, on, or the likes on the videos what you have put in the YouTube channel. Or also it is applicable in Amazon or Amazon Prime or Netflix, isn't it? Where you get a lot of recommendations. So this is based on association analysis. Yeah. Um, Best example is market basket data, where say where we can analyze the customers who bought this item also bought the other item. So this is as many times I gave that example. The customer who bought milk and bread is more likely to purchase a similar item, or milk or cheese is more likely to buy bread. So this is a market basket analysis. So this is about the various data mining techniques. So I have supervised and unsupervised learning, and these are the various um, fields of supervised learning and unsupervised learning. In supervised, I have classification in terms of machine learning, and also with respect to statistics. And unsupervised learning, I have clustering and association analysis. Okay, now let us have some discussion about the various data mining tools and platforms. So data mining tools have been existing from a very long time, but its prominence, the use of such data mining tools are more in use in the recent decade after the rise of the value of the data, especially in the field of big data analytics. Okay. Now let us look into the very wide range of data mining platforms that is available in the market today. And some of them are described as follows. The first one is, so either I can have a simple or a sophisticated data mining tools. So there are an example of a very simple data mining tools are Excel, and you have a very industry level sophisticated tools such as IBM SPSS modeler. Then I can have a standalone or embedded model. So there are many tools which are standalone, and then there are tools that are embedded in an existing transaction processing, or which is embedded with the data warehousing, or it can be embedded with the ERP systems. So I have an option, or there are tools which are standalone or embedded. Okay, then I have open source or commercial. So there is an open source and freely available tools, and then there are commercial products. For example, Veka is a open source product, and IBM SSPS model modeler, and also MS Excel is a commercial model. User interface, yes, of course. There are see, some of the tools provide a graphical user interface where you just have to drag and drop to the tools, and it is very easy to use. And some other requires commands, or you need some programming skills, because these are, some of them are text based tools, and you require some technical knowledge about using the data mining tools. Then we have the data formats. So there are some tools that work on a specific type of data formats that will accept input only in a specific format. And then there are tools that can directly accept the data from many of the popular data management tool formats. So these are the various categories of tools that can be used in that are used in a data mining task. Now let us see the various platforms. Okay, so we have MS Excel, as already mentioned. It is a very simple data mining platform, and it's also a very easy data mining tool. Okay, then we have Veka, as already mentioned, it's an open source and it is a free data mining tool. Then we have R. R is a programming language, we all know that, and it is mainly used for R. Along with Python, I could add Python also here, right? It is very extensive and extensible, and a versatile open source statistical programming language, which is having more than 600 plus libraries and over 1,20,000 functions. And it is very popular with startup companies and increasingly so in the large organizations. Then we have IBM's SPSS model. So this is an enterprise level data mining tool, and it offers a very powerful set of tools and algorithms for most popular data mining capabilities. And it is having a very colorful graphical user interface format with the drag and drop capabilities, and it's very easy to use. And it can also accept the data in multiple formats, including reading from the Excel files directly. Now let us have some comparison over these tools. Okay, let us with these four tools: MS Excel, Vega, R, and IBM's SPSS model. So this is a small comparison with various fields. Okay, various values with respect to, so these are the various features, and these are in columns. We have the various platforms: Excel, R, then IBM's SPSS modeler, and last we have Veka. Okay, so we'll start with the feature ownership. Of course, Excel is commercial. It is owned by, or it is it is developed by Microsoft, right? Whereas IBM SPS model is also commercial and it's very expensive. As see, as the name suggests, as mentioned in the name, it is developed by the IBM. Okay, whereas R is an open source and Veka is open source, as already mentioned, and Veka is free, right? Data mining features, Excel we have very limited because it is very simple and very easy to use, and we all know that it is having some limitations with respect to the way macro functions that is available, and it is extensible with the add-on modules. Okay, when it comes to R, it is very extensive features and it is having unlimited data sizes. IBM SPSS modeler is also having very extensive features and with the unlimited data sizes. Veka is also having extensive features, and performance. There is some performance issues with the large data set. Okay, then let us see whether it is standalone or embedded. Excel is standalone. R is also standalone. IBM SSTR model is embedded with the BI software suites. Okay, so along with this data mining, uh, no, not only IBM SPSS model not only act as a data mining tool, but it is also embedded with the BI software tools where you have data warehousing and other data collection modules which is embedded, okay, and it takes the data from the data warehouses, and Veka is also standalone. Then user skills needed. Excel, it is end users. Of course, R is a programming language, so you require a skilled data miners, and IBM SPSS modeler, you need a skilled BI analyst. You need not have a great programming knowledge, but you need to have a skilled BI analyst to work on this IBM SSPR model, as it is an enterprise level software. Then Veka also you required a skilled BI analyst. When it comes to user interface, with respect to Excel, you have text and click, and it's very easy. R, it is a command line, and it also works on IDEs. Then, as mentioned, IBM's SPSS modeler has a drag and drop provision, and it is also has a great attractive graphical user interfaces. Veka also comes with the graphical user interface, but not so colorful as compared to that of a IBM SPSS modeler. Mostly it is black and white, and text output. It provides a textual output. Okay. Last feature is with respect to the data formats. Excel, it is industry standard, and R will take the data in the format of a CSV file, and IBM SPSS modeler will take a data from variety of data sources or in a variety of data formats. Okay, Veka will take the data from SVS or in the form of an CSV or a proprietary data format. Okay, so this is about a comparison with respect to the various features among the four widely used data mining tools or platforms: Excel, R, IBM's SPSS modeler, and an open source data mining tool, Veka.
Now let us look into another important topic in data mining, that is data mining best practices. Okay, the data mining best practices, here we will be implementing this CRISP data mining cycle, CRISP data mining cycle. This is as seen in the diagram. It is a way of having the best data mining practices for the successful and effective implementation of data mining projects. But before understanding this, how this CRISP data mining cycle works, we should know what are the various aspects of a good data mining projects. See, for the effective and successful implementation of data mining projects, we require skill set from both the business as well as from the IT sectors. So this business aspect helps us to understand the domain and the key questions like like the relationship between the data, and also should be able to help to create a hypothesis to test it. Whereas the IT people or the IT aspects help us to fetch the data from many sources, clean up the data, assemble it to meet the needs of the business problem, and then should be able to successfully run the data mining techniques on the given platform. Okay, and an important element is to go after the problem iteratively. That is what we see as a solution. This is the iterative solution because it is a cycle, isn't it? So the best way to go about the problem is to tackle it iteratively. So it is better to divide and conquer the problem into smaller amounts of data and get closer to the heart of the solution in a iterative sequence of steps. And there are several best practices, among which the best one is cross industry standard process for data mining, that is CRISP. Cross industry, CR stands for cross and I stands for industry, and S stands for standard, P stands for process. So this is cross industry standard process data mining cycle, and it has 6 essential steps. Let us see each one of these steps. The first one is business understanding. This is where it all starts, the business understanding. The first and the most important step in data mining is asking the right business question, and this question should be a good enough, that is implementing a data mining project should be worth all the all the budget or the expenses that goes into the project. So support from the top level executive is very much essential, like any other IT project, for the implementation of data mining project. Second one is about data understanding. So this is this is a very important step to understand the data available for mining, and one needs to be very imaginative and should be thinking out of the box to um, have an hypothesis to solve the problem, and without the relevant data the hypothesis cannot be tested. So the here the skill set is required in understanding the data, as well as the data itself should be required. The sufficient amount of data for running the data mining project is required. Then third step, so these two steps are done, okay, and see if the data understanding is not done, we have to go back to the business understanding. So there is a small cycle here itself, right? So until this is very clear, we cannot go to the third step. And once data understanding is done, then the next step is data preparation. So in the data preparation step, we should see that the data should be relevant, clean, and of high quality, because it is very important to have a high quality data. See, we shouldn't keep some substandard data into the data mining technique, because that will result in garbage in and garbage out. So the data mining project will not be able to provide a very good result, okay. And then it is very important to assemble a team that has a mix of technical as well as business skills, the one who should be able to understand the domain and the data. And the data cleaning, so all the process of data cleaning, that is pre-processing, takes here, okay, and it takes 60 to 70% of the time in data mining project. So this is a very time consuming manual work, and also manual or sub-automated work, and it may be desirable to continue to the experiment and add a new data element from external sources of the data that can help in improve the predictive accuracy, okay. So this is about data preparation. So after this we have to go with modeling. So once the pre-processing of the data is done, we have to go with modeling, okay. So this is the actual task of running many algorithms using the available data to discover if the hypotheses are supported, and a lot of patience is required, because this requires a continuous engaging with the data until we get some good insights into the patterns that we are looking for from the data, okay. And a host of modeling tools and algorithms should be used, and tool may be tried with the different options, such as running different decision tree algorithms with the different parameters, okay. So this is a very rigorous process, so we should do this until we are satisfied with the insights that is obtained from the modeling, okay. Then we have model evaluation. So after this we go with model evaluation. So here one should not expect what the data say at first. It is better to triangulate the analysis by applying multiple data mining techniques and conducting many what if scenarios, okay. And one should evaluate and improve the model's predictive accuracy with the more test data, and when the accuracy has reached a satisfactory level, then the model should be deployed, okay. So after evaluation, this is a normal technique what we do in our machine learning project also, right? One, we will see if we get 7, for example, with the classification problem, if we get 70% accuracy, we will not be satisfied with the 70%. So what we do, we try and test with the different data mining technique. So we go back and try again with the different algorithms or different techniques, change the parameters of same algorithm multiple times until we get a better result, right? So if the results takes me up from 70 to 75, then it is totally worth the time in spending spending with the evaluation, or in conducting new experiments, right? So this is how so after this we go back to the business understanding if we are not satisfied with the result what we got from the evaluation. So if we are very satisfied with the evaluation, then we can go with deployment of the project, okay. So the last step is deployment. So this is about dissemination and rollout. So it is very important that the data mining solution is presented to the key stakeholders and is deployed in the organizations. Otherwise the project will be a waste of time, and a major setback for establishing and supporting the database decision procedure culture in the organization, and the model should be eventually embedded in the organization's business process. Okay, so this is about the crisp data mining cycle. So as you can see, it is a iterative sequence of iterative steps that will result in a deployment or of a good data mining implementation. Okay, so this is about the data mining best practices by implementing the crisp data mining cycle. Okay, the next topic on data mining is data mining mistakes. So here we will be looking into the common mistakes that is done in a data mining project and how it should be avoided. The first one is selecting the wrong problem for data mining. So this normally happens when the data mining project is implemented without properly understanding the problem statement and without having a proper goal set. So this will lead to a waste of time because for example, if you apply a clustering technique for a classification problem, then obviously it will result in some illogical outcomes, right, which is of no use, and this is just a waste of time and resources, right? So such kind of problem should be avoided by having a clear cut understanding about the problem statement and having the right objective and goals. Okay, so this is very much essential to have a successful data mining project, that is not selecting the wrong problem for data mining. Second one is buried under mountains of data without clear metadata. So what is buried under mountains of data is so this means having a lot of data but not having a required data, or in other word, uh, there is a common myth that uh, the more the data, the better the data mining project is, or the better the outcome of the data mining project. That is actually wrong. You require data, but you require only a quality clean data, right? The data need to be properly cleaned, organized. So basically it has to be pre-processed in a right manner. So normally a data mining project will take 60 to 70% of time in cleaning, okay, or in pre-processing. So if a lot of time is not given in pre-processing, that is if the data is not clearly understood, and if it is implemented without having a clear knowledge about the data, that is without having a metadata, then it will yield, the data mining result will yield in a erroneous or illogical output. Okay, so this should be avoided. Okay, the next point is disorganized data mining. So this is disorganized data mining is a data mining project without clear goals. So here much time is wasted doing the same test using the same mining algorithms repeatedly and blindly, and this can come out from being a very sloppy about keeping track of the data mining procedures and result. Not leaving sufficient time for the data acquisition, selection and preparation can lead to a decreased data quality, and it will result in garbage in and garbage out. Similarly, not providing enough time for the testing the model, training the users and deploying the system can make the project a big failure. Next point is insufficient business knowledge. So without having a deep understanding of the business domain, the results would be very gibberish and meaningless. And one should not make erroneous assumptions, and one should not ignore the suspicious findings and quickly move on. And one should be open to the surprises, even when insights emerge at one level. It is very important to slice and dice the data at other level to see if more powerful insights can be extracted. Next one is incompatibility of the data mining tools and data set. So this is about the tools. So all the tools from the data gathering, preparation, mining and visualization should work together. So say there should be a synchronization between the data mining and the data visualization and the various other tools that goes along with the data mining tools. Okay, and you should use these tools use of these tools can work with the data from multiple sources in multiple industry standard formats. Next one is looking only at aggregated results and not at individual records or predictions. So this is also one of the data mining mistakes. So looking only at the aggregated level results only at the aggregated level and not inspecting the individual records and predictions. The last point about data mining mistakes are not measuring your results differently from the way your sponsor measures them. So this is about see, if the data mining team loses its sense of business objectives and beginning to mine the data for its own sake, then it will lose respect and executive support very quickly. And one should remember to make use of the BIDM cycles, what we have initially learned in business intelligence in our previous lecture video. So that should always be remembered and should be considered while performing the data mining projects. The last topic of data mining is about data mining myths. So let us see some of the common myths about data mining, some wrong assumptions regarding data mining concepts. The first one is data mining is all about algorithms. So this is a one big myth about data mining, a wrong assumption regarding data mining, that data mining is about algorithm. Yes, of course, data mining requires algorithm, but it is not only about the algorithms. For an efficient and successful data mining outcome, we require a clean and effective, efficient quality data, right? So data gathering, pre-processing of the data, that is cleaning of data, is very much essential. And actually the pre-processing takes 60 to 70% of the time of the entire data mining project. So a lot of manual effort and time is required in cleaning the data, because we don't want garbage in and garbage out, right? So cleaning the data plays a major role in the success of a data mining projects. So it is not only about the algorithms. Second point, data mining is about predictive accuracy. No, the data mining is not about predictive accuracy. So predictive accuracy is one of the evaluation techniques for normally for a classification problem. And again, if the data is not balanced, you cannot go with the predictive accuracy also. So it is not only about the predictive accuracy. There are many evaluation metrics to judge the data mining, to evaluate the data mining projects. So there is a precision, there is a recall, then there is F1 score, and predictive accuracy is definitely one of the most commonly used evaluation technique, but it is not the only one. And so this is another myth about data mining, that thinking that it is about calculating the accuracy. And of course the some of the data mining techniques like clustering and association analysis cannot be judged or cannot be evaluated, because the data is not labeled, right? So we have unsupervised, in the unsupervised learning, we don't have a right result, or we don't have a evaluation metric to judge the quality of data outcome of the data mining project. So it is not about predictive accuracy. Third one is data mining requires a data warehouse. So this is another wrong assumption. Of course, if the data warehouse, normally in a very structured organization, the data to the data mining task will come from the data warehouses, because the data warehouse will have a very clean organized data. But it is not necessary that the data has to come from the data warehouse. The data can have multiple sources. So this is another wrong assumption about data mining, that the data has to be fed from data warehouses. No, answer is no. But if the data comes from the data warehouses, it is well and good, because the data will be cleaned and it will be of high quality. Okay, the next myth is myth number 4, that is data mining requires large quantities of data. So this is again a wrong misconception. Many interesting data mining exercises are done using a small or medium sized data sets at a very low cost and by using end user tools. And you see, I would like to put it in this way. It is not about having the large quantity of data, but it's about having the right quality of data, clean pre-processed data, which is very clean, and which is organized. Okay, so that is what you want for a data mining project. The last myth is myth number 5, that is data mining requires a technology expert. So this is again a wrong misconception. Many interesting data mining exercises are done by the end users and executives using a simple everyday tools like spreadsheets, and uh, the business executives may make use of some tools which provides graphical user interfaces where you don't require the knowledge about data mining algorithms. So requiring the being a technology expert for to run a data mining project is another myth. Of course, if you are using programming languages like R or Python, then you require expertise in understanding the various aspects of the tools. But if you are using a graphical user interface uh, tools, there are many efficient tools like the business intelligence tool provided by IBM, right? So where you don't require a lot of insights about the working of the data mining techniques and algorithms. So these are the various myths about data mining. And with this, we come to the end of this chapter, that is data mining. Um, Thank you for listening. Have a nice time. I'll see you all in the next one, the data visualization. Bye bye.